Good morning, children. In the chapter Motion in a Plane, we have the next topic is circular motion. If the object is moving in a circular path, then it is called circular motion. For example, motion of the planet around the sun, or you can say that motion of the fan around its axis, or you can say that revolution of the electron around the nucleus. That is all the examples of circular motion. In the circular motion, we have some definitions. First is angular displacement. Angular displacement. We know in the angular displacement, if the object is moving in a circular path, then it is a. Suppose the object is moving in a circular path along the path AB. Then for the circular path, then AB is called arc. Then OA. Here OA is called radius. Then this arc makes an angle theta at the center. Then this angle is known as angular displacement. So now we can define as angle traced out by the radius vector at the center of circle. Now we know angle theta is equal to arc by radius. So the unit of angle is radian. Now next definition is angular velocity omega. Angular velocity, simply we know the definition of velocity, that is rate of change of displacement. So here we can write here angular velocity is rate of change of angular displacement. So we can write here omega, that is equals to d by dt of theta. Now we can write angular velocity omega is equal to d by dt of theta. So the unit will be angular displacement is radian, time is second, so the units will be radian per second. Now we can find the angular velocity, because angular velocity is you can say that it is a pseudo vector. So we can find the direction of the angular velocity. Suppose we can find it by the right hand thumb rule like this. Here the thumb gives the direction, and here the curl. If we curl our fingers, then in the direction in which we curl the finger, that is the direction of motion of the object. Suppose in the first case, object is moving in the anti-clockwise direction like this. Object is moving in the anti-clockwise direction. This is the direction. So thumb, it points upward. So the direction of angular velocity, that will be upward. In the case of second, when the object is moving clockwise, we can say this is like clockwise direction, this is clockwise direction. If it is a clockwise direction, then thumb points downward, so the direction of angular velocity, that will be downward. Next definition is time period. Time taken to complete one revolution is known as time period. And we know the definition of frequency, number of vibrations completed in 1 second, that is known as frequency. Now we can find the relation between the time period and frequency. We know here frequency is equal to 1 by time. So the relation between the time period and frequency, that is equals to f is equal to 1 by t. Now the next topic is relation between the linear velocity and angular velocity. Suppose the object is moving in a circular path. In time, we can say small time, that is delta t. The object is moving from the point P to Q. Now here delta L is length of the arc, OP here is the radius, and the length PQ, it is of length dr, then OQ, that will be r plus dr. If the object is moving in a circular path, then its angular velocity is omega. Now we know angular velocity omega, that is equals to, this is angle made by the radius vector at the center. Here it is delta theta, we can see. So angular velocity is angular displacement upon time taken. So omega, that will be equals to delta theta upon into delta t. Now we know linear velocity v. Velocity is equal to distance upon time. So the length, that is delta L here, and the time taken is t. So we can find the value of delta L from here. Delta L, that is equals to V into delta t, we can write here. Now we can write here angular displacement. Delta theta is equal to, angle theta is equal to arc upon radius. So this will be equals to delta L upon radius into r. From here we can find the value of delta L. This is equals to r into delta theta. This is equation number first. This is equation number second. Now in the equation second, put value of delta L. In the equation number second. So we can write here V is equal to r into delta theta upon delta t. According to equation number first, delta theta upon delta t is equal to omega. So we can write here V is equal to r into omega. So the relation between linear velocity and angular velocity, we can write here V is equal to r into omega, or in the vector form we can write here V vector is equal to r cross omega. This is called vector form. Now the next topic is angular acceleration. It is defined as rate of change of angular velocity. So alpha is equal to d by dt of omega, or we can write alpha is equal to d omega upon dt. The units of angular acceleration will be radian per second square. Similarly, we can find the direction of angular acceleration by using the right hand rule. Same earlier we have explained in the angular velocity. If the object is moving in the anti-clockwise direction like this, anti-clockwise, then here thumb points upward, so direction of angular acceleration, that will be upward. If the object is moving downward, if the object is moving in the clockwise direction like this, then the direction of angular acceleration, that will be downward. Now the relation between linear acceleration and angular acceleration, we can write here V is equal to omega into r. Differentiate, we can write here dv upon dt, that is equals to r into d omega upon dt. dv upon dt, velocity upon time, acceleration, r into angular velocity upon time, that is angular acceleration. So a is equal to r into alpha. In the vector form, we can write here vector a is equal to r cross alpha.